All right. So welcome everyone. My name is Adolfo Garcia, and usually I go by Puerco. I am a software engineer in a super small new startup called Carabiner Systems, but today I'm here because I'm also part of the release engineering team with Kubernetes, and I am also one of the technical leads of the OpenVEX project in the Open Source Security Foundation. So me being here on the stage is like wearing both hats, which is, I don't know, kind of why we want to present the new tools. So this is, I'm going to rush through the talk because it's like I only have half an hour. So the goals are this one. So this talk has a VEX introduction, which I usually wouldn't do in this setting because we're all familiar and experts on things like VEX. But something that became relevant last year at this very conference is that we have a lot of different points of view on how VEX works, how to consume them, the experiences. So you're going to see that the experience for our VEX work is completely different to what was just presented. In the maturity levels of different aspects are different. So probably I'll just rush to that. And then we're going to talk about what the difficulties are on assembling VEX or Kubernetes, such a large project with many different stakeholders. A few tools that we developed that enabled us to do the VEX feeds. And so I have a demo, but since I cannot have my credentials here, I put together like a children's storybook with screenshots so that we can see it in action. All right, so let's go through it. So what is VEX? So VEX, you know, and it's a chronological system of documents where you issue impact assessments of vulnerabilities on your product. So if my product has a vulnerability, does it affect me or not? And the evolution of that knowledge over time. So this is how we see VEX working. Especially this is mostly the way we see VEX working in OpenVEX. So let's say that you have your product. In our case, it's not a big enterprise product. It's an artifact. So think about a container image or a binary. So usually you would take your scanners, point at them. They will find vulnerabilities. And those vulnerabilities, most of the time, will come from dependencies. In the case of container images, a lot of them come from the operating system dependencies installed in the image or the language dependencies of the application itself. Now with VEX, we produce a document that ties together the product, the component, and that vulnerability, and essentially issues. So you have that document, and then when you point the scanners at your product again, you feed that that document to the scanners, and they will still find a vulnerability, but based on the assessment contained in the VEX document, they may choose to suppress that from the input. Basically, the dream that they were just discussing in the previous talk in OpenVEX is a reality. So both Trivy and Gripe already support natively the ingestion of OpenVEX documents. And not only ingesting them, but there are some discovery capabilities as well. So you can attach, if you publish a container image, we can attach the documents signed together with the container image, and the scanner is able to retrieve them from the registry and automatically suppress the vulnerabilities, or show them to you depending on your configuration. So as we said together, bring together product, vulnerability, and the four status messages of VEX under investigation, affected, not affected, and fixed. So this can, so you can issue one VEX statement if you know the final assessment, but also we also support the idea of, okay, this is a like evolution that changes. There's an evolution of knowledge that happens over time. So you want to make sure that you are able to push that. And why is, so there are 4 flavors of VEX today. So there's CSAF, which is kind of the big brother of VEX, the Common Security Advisory Framework. There's a VEX flavor in both SBOM standards, one in Stacklok and one in SPDX, and of course, the flavor that we're growing in the OpenSSF, OpenVEX. So OpenVEX was designed from the beginning to be VEX and only VEX. So we don't support, so it's designed to be super thin, lean, and it's linked data. It's written in JSON LD. And it is designed to be embedded in other supporting formats, such as attestations. This becomes especially important because when you have mandates like the CRA, which is requiring the shipping of products without known vulnerabilities, well, we think that there may be, I mean, this is still under discussion, but we think that there is a future where you can provide a security scan and pair it together with a VEX document to fulfill all of these requirements. So VEX has potential answers for some of these questions, like did you fix your vulnerabilities already? Do you want to communicate the impact they have on your product, and all of those questions. We're gonna see a demo on how you could potentially stop the release of a non-compliant artifact with known vulnerabilities, just as an example of the tooling that we've built. So going back to vexing Kubernetes. So the problem with vexing Kubernetes comes from many different angles. One is the generation of the information itself, because there are open questions on every aspect. So for example, who can issue the VEX documents? If someone from the project is gonna issue an assessment if a vulnerability impacts the code or not, who has authority to do that? How do you check that the VEX statements that we release are actually from the people that are supposed to own them? Who signs the artifacts? And then there's a question of, okay, so this is open source, it's moving constantly. How do we keep track of everything? Then there's other kinds of information that you need to mix in, like to add to the mix, like our CVE feed. Kubernetes is a CVE numbering authority. So our advisories, how do they play into the whole VEX system that we are building? And then there's of course the question of publishing. So we can publish those documents along with the built artifacts, but then there is a life cycle that comes to them. Like they could be changing, and then you should always consider them to be in constant motion. So where do we put them once they're done? We don't have answers for 100% of all of these problems, but I think we had some satisfactory answers for most of them. Now, this is like a problem encompassing all areas of the project, because like you could have a vulnerability showing up in a Go module in storage or in networking. So it needs like project-wide coordination. So the VEX effort currently is being coordinated between SIG Release, which is the group that I'm a part of. We build all of the supply chain security features of the Kubernetes release process, and also SIG Security, who care for the overall security of the project. And also the third secret partner here is the Security Response Committee, who issues the Kubernetes security advisories. So how are we planning to do the Kubernetes VEX feed? All right, so this is the dream, the VEX feed of Kubernetes. So we were thinking, so what would the ideal VEX feed for the project would look like? And so there are many sources for it, and we identified three kinds of VEX feeds that will all converge into this final one. The first one is like vexing the vulnerabilities in the Kubernetes components. That is information from the CVEs that scanners are picking up in the dependencies, in the Go dependencies of the project. Now this one is number one, but in reality, it is composed of two feeds. The first one is the Go vuln check, automatic detected non-impact of vulnerabilities. So we are starting to run Go vuln check, which is a tool from the Go toolchain that analyzes the reachability of vulnerabilities. So Go vuln check using the compiler. The Go compiler can tell you if a certain vulnerability actually in your components is actually triggered by the code. That's the first one. And the other is just experience from the maintainer. So if there is a vulnerability that the maintainers are sure that they don't affect the project, we want them to make sure to make sure that they can issue their assessments as well. The second feed. So that's Go vuln check, the maintainers. And the second feed is the VEX from the Kubernetes security advisories. So when you think about it, the advisories are like a negative VEX because it's like, basically, we want to complete the VEX picture by telling you, okay, so we release advisories telling you there's a vulnerability in the, let's say, kube proxy image for Windows AMD 64. That means we can issue a VEX for that, telling you that that component is affected, but we can, from the advisory data, derive the other, all of the other artifacts telling you that you are not affected if you're using those. I don't know if that makes any sense or not. The advisory tells you, okay, you're affected in this tree, but the other 50 artifacts are not affected. Basically, that's it. And then, so to do that, we are starting to rewrite our the code that issues the advisories. So we want to move the generation of the advisory data earlier and start with the OSV format, the open source vulnerabilities format. And then from that one, we can derive all of the other vulnerability data that we need. Like from that we generate the advisories, the feed. We generate the JSON that we ship to the CV database, and then we also capture that to generate the release notes and tell you what's affected. And then also from the OSV feed, we can generate the VEXs. And the final one, and we won't go into detail because there's a lot of open questions still on this one, is the vulnerabilities found in the base images of Kubernetes. So Kubernetes builds and releases images that are pulled thousands, maybe millions of times every month. And those images are static. Once we build them, they are never upgraded. So we need to also address the vulnerabilities found there. And then, so once we have the Kubernetes VEX feed, there's a question of what do we do with them. So we take all of that VEX data, and then the current immediate plan is to start pushing the VEX statements attached to the images in the registry. So that's the first one. Then we're thinking about building a stream, a VEX feed, basically the stream of all of the statements that we release, all of them just in a single line. And then we can also collaborate with that data in other efforts, such as Aqua's VEX Hub, which is a repository of open source VEX information. So, so we right now are at the point where we have implemented 1A and 1B. And we're working on number 2, which is rewriting all of the advisory generation from the beginning. Okay, and so how do we did it? So the first one, go vuln check, is simply running. So go vuln check, the native Go tool, can issue OpenVEX natively. So you just pass it instead of pass it the format OpenVEX, and it will spit out that information in OpenVEX format. So we've been working on 1B, which is how do we capture the assessment from maintainers. And so I have to give credit where credit is due. So there are some folks here that showed very cool demos last year that really inspired us to think, okay, so how can engineers come and issue their opinions on the piece of software that they are in charge of so that we can generate the VEX. So so we came up with this new VEXflow tool. So how does it work? This is at its core how it works. So let's say that you have your code, your repository. Now, we start scanning periodically the branch. Like we run OSV scanner, running, and then, so it's important to understand that Kubernetes always has 3 or 4 branches under maintenance, which we need to VEX constantly. So we scan each branch, and whenever there is a vulnerability found, VEXflow takes the vulnerability and opens an issue on GitHub so that you can triage that vulnerability. By the way, this tool is most likely, so we're having these discussions on whether we're gonna host it in Kubernetes or in OpenVEX, but it's already open source and you can use it. So it opens this triage issue. It has all of the information from the vulnerability. And then the next step is, so the first thing you can do is do nothing. Like, okay, it's a vulnerability, and then you just leave it there. And then after a while, it'll auto-close the issue, and you forget about it. But the other is when there's a VEX statement to be issued, one of the maintainers can take a look at that, and then based on their expertise, they can do their assessment. How do we know who can issue the VEX statements? This tool uses, for those who are familiar, Kubernetes has the owners file, which is a way of creating a structure of a structured permissions layer. So at the very top of a directory, you put an owners file, and then you create a subdirectory with other owners. So we have native support for that. So the idea is that if you are giving permissions on some area of the code, you can come and issue your assessment. Then the maintainer can issue their assessment. We'll see how in a little bit. And then once they generate the assessment, we generate the OpenVEX document, sign it with Sigstore, and then we publish it to the GitHub attestation store. Since we're generating this inside of GitHub Actions, we sign the VEX, push it out up there. It can be stored anywhere, really. And then so the issue closes in there. So after this process, you end up with one attestation, one VEX document stored in there. Some things to note is, okay, so I'm gonna do the demo, like the storybook demo to show you how it works. So I built this demo about there's a lab for this project that has a project that is specially crafted. So by the way, if anyone wants to see this live, I can do it. Just look for me in the next couple of days and we can go over it. So we have a demo repo that has 2 vulnerabilities in it. So it's specially crafted to have those 2. One, the code never exploits it, but it's still picked up by the scanner, and the other is not exploitable and is picked up by vuln check, so it can issue the VEXs. So this project has a very simple release process. You have a bunch of Go files, you compile them, and release. So the idea here is that in order, for example, to make this compliant with the CRA, no exploitable vulnerabilities. So we were thinking, okay, so how do we do that? So what we do is we start scanning and establish a policy, like break this if there are vulnerabilities. So we effectively establish a check. If something goes wrong, it fails. So we can check so we generate an attestation of the vulnerability scan, and if there are still vulnerabilities, the policy fails. So the next thing that happens is, hold on. Okay, so we have a GitHub Actions process running, and then it creates the triage issue, and then this is how maintainers interact with the project. We have a chat ops interface where you come and issue the assessment. So you say not affected, the VEX justification of why it is not affected, like the machine readable one, and then below in the rest of the comment, the maintainers can add like their commentary on why they think this is not affected. We currently only handle one assessment. So if one person says, okay, we ship it, but we are also thinking, well, maybe we need to have 2 or 3. Why not? And then, so after someone authorized in the owner's file issues the assessment, the bot comes in, picks up the assessment that they did, transforms it to OpenVEX, and pushes it to the attestation store. So at that point, you can see here, this is all screenshots from the demo, not running live, but so below, we have the attestation generated by VexFlow, the tool that we built. And on top of that is an attestation of the Go vuln check output. So I have another, for the demo, I have another job that runs go vuln check, generates a VEX, signs it, and uploads it to the GitHub attestation store. So once we have these two, we can basically collate them into the final VEX document. So this, if you see at the very top, there's the assemble subcommand, and you tell it which repository to you're working on. Like in that case would be Kubernetes. The triage repository is where VexFlow is generating all of the assessments, and then so what it will do in this final stage is that it'll go scan the repository, get the currently present vulnerabilities, because as the project moves over time between release and release, modules may come up with vulnerabilities, but they may disappear because, like, let's say a vulnerability was upgraded. So in that case, we still have all of the information for the branch, but the final assembly of the document only picks up the documents that apply to the vulnerabilities at release point. So it grabs everything, and then and the other important thing is, during the whole triage process, we are generating vexes for the branch, not for the final artifact. Okay, but this final process gives you the chance of saying, okay, so this is the vex for my branch, but also you can add more subjects to the resulting attestation, to the vex product, to also specify your container images. So you have your container images built, and then you grab all of the data from, like, storing the attestations and merge them together, and you have VEX that applies to the vulnerability. And then, so once you have this, you feed it to your policy engine, and it passes, and then the project gets released. So this is kind of the way we are doing it now. We started running a couple of tests, and everything seems to be working really well. And yeah, so at this point, I would show you the documents in the demo, but I'm happy to return to any of the previous slides. But yeah, so that's it. So the tool is currently hosted here. It'll probably move to OpenVEX or Kubernetes, depending on what happens in the next couple of weeks. And so if anybody is interested in joining the projects, we have a regular release engineering meeting in SIG release. We meet every Tuesday, alternating times. And we have every other Monday, we have the community meetings for OpenVEX, where we discuss all of the tooling and all of that. And yeah, this is me. If you want to look for me for ask questions, whatever. Yeah, so that's it. With 5 minutes for questions, if there are any.
Hello. Hi, Munawar Hafiz, Open Refactory. So we are having this discussion with the Apache Software Foundation, like multiple maintainers, regarding whether it is good or okay to release a VEX statement and have this in a public discussion, because that information might also be useful for attackers. Like if something is reachable at a particular project from a vulnerability is reachable or not, that information might be used, because there's always an air gap between like between the patch happening and so on. So in your case, if I understood it correctly, there was a document that was created for open discussion. Was that done in open format, or did you guys encounter any feedback on this, like whether this works and so on? Thank you.
So the question is whether or not to quickly issue the vexes, or like be more transparent or less transparent. Is that, or around process, or both? Well, so in our case, it's less opportunities, because the vulnerabilities are there, and we're in our case, in our specific case, we're only releasing information of vulnerabilities that are not affecting the product. So if you were to approach and see, okay, these are the list of vulnerabilities, the ones that you find vexed, at least in this initial stage, are not exploitable. So it works against the attacker. In the case of the second feed, which is the advisories, the one derived from our advisories, that gets released derived from the advisory data, which means it already passed through the SRC revision. The distributors were already notified, and the embargo time passed. Kubernetes has an embargo time to let people adapt, and we already have the new release published with the patch in it. So it's not worse than the advisory. So it's only another channel of notifying them of the same impact.
You mentioned for the Go vulns that you are getting VEX from the maintainer assessments. Is that just the ones in the Kubernetes project, or you're also finding VEX from other Go open source projects?
So it's the maintainers issue their assessment on the Go dependencies that the project uses only for Kubernetes.
Okay.
So we can offer this to other projects inside of the same org if they want.
Yeah.
But right now it's only for Kubernetes.
Okay. I had one more question. Oh, you mentioned that you're scanning the source code and you're storing the VEX for the source code, but you're releasing the images, right?
Yeah.
So do you scan the image with a different scanner and then see which vulnerabilities show up and then pull those from the source code?
Exactly. So
Okay.
we scan the commit, so the build point.
Okay.
We do the scanning there, and then everything that doesn't show up, we simply discard them. Now, they are kept in because the GitHub attestation story is read only, so they're there for historical purposes. But when we turn the VEX from the branch to the final image, we only carry forward those that apply.
Cool.
Yeah.
That's really cool. Thanks.
Any more questions? Let's eat.
Perfect.
Thank you, Alfonso.
Thank you.